Well, hi, good morning, and thank you for joining me. In my shop today is February 25th, and I really do appreciate you hanging in here because I'm watching these videos and I'm having a tough time coming in here day after day and slugging it out with this machine. When I first put it on my bench, I thought maybe 2 days to get through the process, and it's 15 days down the road here. Oh my gosh. So yes, at the end of yesterday's session I realized I had not removed this resistor, and son of a gun, exactly how much it would have thrown everything else off, I'm not sure. It's just the reason why I'm getting only half the GM measurement that I should get. Maybe so. But before I pursue all this, I showed you this great big tube the other day. This gigantic tube here. This is a 354A Western electric tube, and part of it is broken away. This part that's laying here is actually supposed to be up at the top. Well, I found his younger brother. So this is basically identical to this tube, just half the size all around. And this one, this is a plate cap, by the way, so this is a large insulator here. So this is where the plate voltage is being applied. There's a cat crawling up my pants here. Can you see that there's just a disc under here, just sitting? I'm sorry about the lighting. I'm gonna have to do something to make some really nice lighting for looking at these tubes. The plate is just a disc suspended from the top. You can see on this one the plate has come off the suspension point and it's just fallen. It's wedged down here right now. If I shook that hard enough, it would come loose and wander around inside. So I think this is kind of weird. This is a triode. I thought it was a rectifier. This is a triode. And how exactly this thing works, I don't know. This circular basket part here, would that be the grid? And it's hard to see, of course, in the camera, but in the top of this weird can here is a small hole aimed up at the plate at the top. So assumably electrons are coming out of the small hole. We should be able to see that. We'll look at this one. This one's got many holes. I don't know how this is supposed to work, but I think this is revealing something about tubes that we don't normally see or think about. The small one is a 287A. Both Western electric tubes. This one would go in a socket on my tube tester. No. I've never seen a socket that big before. Okay, that's the end of the fun part. Now we have to turn attention to this machine. I'm going to have to remove this resistor from here and repeat the GM test for either tube. Probably for the 6C4, and see if it still is half what it's supposed to be. Okay, well, I got some hope here anyway that I've got something that's going to fix the problem. Okay, we're ready to go here. I've double checked this. It's set for the 6C4. Here we go. Just giving a minute here to warm up. Oh, I can do the weather report. The weather report today. Yesterday, it got up to 6 degrees outside. I couldn't believe it. 6 is surprisingly warm. Got down to freezing overnight, not below freezing, and today it's above freezing, and it'll stay that way all day. Consequently, vast amounts of stuff is melting around here, and some people, not here where I live, but in other parts of the province, are starting to wonder, is all this snow we got going to lead to flooding? And that's a real concern. Not for me here. Okay, we need to set line and bias, so let's do that. I'm going to put this up just somewhere so it's up higher. Not that high, yeah. Roughly. Ooh, what's going on? There's always something going on here. That's weird. What, like... I don't know what was going on there. Okay, we'll turn it down a little bit. Put the line on and we'll adjust the line. Then we'll adjust the bias. 4.8. Okay, we'll adjust the line again. Line is good. Bias is good. Ready to test. Let's do the process here. We'll go around short on 1, 3, 4, 5. No, 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 no. No, no, no. We are ready to test. There we go. Oh, it's still way, way, way down there. It's lower, if anything. Today, this tube is coming in at, we're on the E3 scale. Well, you could call it 400. Yeah, 400 micromos. When, oh my gosh, I don't know what's going on here at all now. I wrote down 1300. That's the reject point, isn't it? It's right here. Yeah, that's the reject point. So that didn't work. That's bottom line. Took the resistor off, didn't make any difference. Phooey. That's a real phooey. I'm just looking to see, is there anything I'm doing stupid here? It's worth looking. No. I don't see anything stupid here. Am I reading the scale stupidly? Can we just change scales here? I don't think so, but 3, and GM scale 3 for sure. That's 1. That's 500. This is 1000. This is 500. It's 400. It's 400. Let's do the EM test on this tube. Okay, EM test. Here we go. Take it off, hold. EM test. BEBD 9. B, so we're changing a lot here. B, E, D, B rather, D, 9. Okay, now last time I did this EM test, I set the bias incorrectly. I didn't do it properly, so in this case the bias should be set to number 15. That's why there's no V there. So that's set to the number 15. And when we do the test, we're looking at replacing good on here. Get rid of that tube. Replace that baby. Well, the two both tests are indicating a replacement. They should replace this tube. So that both of them are working that way. Yesterday I measured the B plus voltage and I got something that I thought is probably not correct. It looked like a full wave rectified high voltage, but not a pulsating DC. That's not what it looked like. Okay, I'm going to find in the manual where it talks about pulsating DC and where you're looking for it, because it wasn't on the front panel, somewhere underneath, I think. And we're going to try to replicate that and find out what's going on, because I think it's pretty strong indications that there's something still out of sorts with this. You know, it's probably me. It usually is. Okay, let's see what happens here. I've got the voltmeter connected to the plate terminal, and I've also got the scope also connected to the plate terminal. And you can see some information at the top right there under plate voltage switch. This is the plate voltage switch. I'm going to switch it over to G. I'm going to put all these on G as if I'm doing a GM test. So supposedly this machine will now, plus I have to set this to 4, I believe. Geez, is that right here? Yes, it is. Switch 4 goes to plate. Good. So if I switch the 0 to 4. Then we will have the plate supply on this plate. Why didn't call this terminal O terminal or something like that? That's the thinking. Okay, and of course I got the oscilloscope going too. So what we're supposed to see is pulsating DC, 160 volts of pulsating DC. So does that mean a meter like this would read 160? Probably that's what they're trying to say. That the wave shape of the voltage, regardless of what it is, will result in 160 showing up on your meter. This is a digital meter. Back in the day when this stuff was written up, this would be the kind of meter would be this type of meter here. So anyway, let's give it a go and see what happens. So right now we're on the G. Okay, so we should see 160 volts show up. That's if I've interpreted all this right too. Plus this has to be on test, I'm pretty sure. Let's let it warm up a bit. I do not have a tube in. Okay, we'll throw this onto test and let's see if we... There we are, look at that. So there it is, jumping up. So on the scope, that says to me that's perfect because this is a pulsating DC. It's not coming down to 0. But let me just check, make sure. That's the 0. So see, it's definitely above. And I'm going to 5 times 10, 50. It's 50 volts, elevated. But on the voltmeter, I'm seeing 116. The actual voltage here would be the peak voltage anyway, 50, 100, 150, 175 or something of that sort on the peak. We could try a different meter and see if we still get the same reading, because a different meter may read this kind of thing differently. Yeah, okay, we'll give it a try. Well, we'll know if it's not right. We're on the DC. Okay, the scale here is 150 volts full scale. Will it go full scale? So it's reading, just about got it there. So I would say on the 150 volt scale, that's 110, 120, that's about 117. So it's exactly the same as this, which is interesting in itself. So now it raises an interesting question. Since this is not showing the proper voltage here, is that why the GM reading is low? So there's a bunch more outputs that will come out of here. They're all AC voltages and they range quite high. So let's take a look at those. That's the best I can do is 50 volts per division on here. I believe we go to A is the low voltage, and as we go up, voltage gets higher and higher. I'll switch my meter over to AC. Well, that's interesting. What would this read on AC? 36. 42 on that scale. 36 on this scale. It's because of the weird wave shape, I would say. Okay, we're going to flip it over now. We'll see what happens. Okay, now we have a much more normal looking AC wave. We're getting a reading of 14 volts. If we look at the what the supply should be, assuming when they say 20 volts they mean as read on a meter like this. And this should be correct now because it's a proper wave shape. 14 volts. It says 20 on the chart. I wonder if this is coming straight off a transformer. Oh, wait a minute. What are we operating at here? Jim. 101 volts. Oh my gosh, I boobed this all up. Here we go. Start over. Everybody start over. Everybody go back. Going back's easy. Put that like that. Put that like that. Okay, so now you can see it's a little bit of a bigger voltage here. What do we have? We're at 115 volts supplied to the machine. And did I align? Check it. I did not. I better do this. You can see the scope going up and down a little bit, not much. What about this voltage? This going up and down. What if I set it to 160? That's interesting. Look at this. 160 and the meter's almost in the middle, which is kind of interesting. Let me set the meter in the middle. So 146, but we saw 160 was possible. Was there an adjustment for that? Did I test that tube with the dim bulb in? Is that why it tested low? Oh my gosh, is my brain attached to my spinal cord? Okay, so we'll make the other readings now and see how they compare. So we'll go to A. Again, A is supposed to be 20. 115 volts coming in, and checking the line setting again. It shows it high, if anything. That's kind of odd. I would go high from just doing this. Funny stuff is happening. Instead of 20, we get 16. I wouldn't want to try to measure it with this. That's pretty tough. Looks like one division basically from peak to peak. So that would be 50 volts. 50 volts peak to peak. That's 25 peak. That's going to be about, it's right around 20 volts. But not on here. What about that other meter? What about the other meter? This is now 50 volts full scale. Oh, AC. Oh, AC. That's not getting a reading. Oh, because I've turned it off. That's why. Yeah, I've noticed that none of my equipment works well when it's switched off. Okay, still coming up a little bit. It's reading 15 right now. It's going to climb up to, I bet you it'll get to 16. The same as this again. Okay, again, that's interesting in itself. Next voltage up. B should be 50 volts. 41 volts. And the next one should be, C should be 160. Oh, I'm going a little high here, but I can't do much about what's going on up here. And the last one, the next one is 160, the same. Not quite the same. And then the last one is a big whopper, 300 volts. Well, I had this online the whole time. Doesn't make any difference. I guess it wouldn't make much difference here really. This is a meter control switch, so you're just switching the meter to different things. Shouldn't affect it. Well, it's definitely not one, where are we now? We're on C. C should be 160. Let me see, 140. Okay, I want to think about that just a little bit. Maybe there's an adjustment that I didn't get right before. So when I look at the schematic here, things look quite simple to me, in fact. So if we look here, here's the big rectifier that's going to produce the DC component that is supposed to be elevating the, or creating, or part of the pulsating DC. So if we follow the output line, let me just change it. Here we are. Follow here. Sorry, I don't have a pointer. I have to use this I-beam. The center tab here. Follow it up. Notice there's a capacitor there. Follow it up over. comes on to terminal number 12 here. You see terminal number 1 has the long is on the is a permanent connected one. So in other words, this control is selecting what gets connected to number 1. In the current position, it's showing the output from here. This would be the DC 160 volts, I guess pulsating right here. See, how do you get this elevated? Okay, but anyway, I'll just carry on. Right? Maybe this guy right here is the elevator. Maybe, I don't know. So following along though, if you snap the switch from 12 to 11, now you're connected to a winding in this transformer, secondary. If you snap it around, round, you eventually get connected to this. And this has to be the different AC voltages, and this is probably the high stuff. The 300 is probably coming out of here. I'm not sure. Let's see, the center tap's not showing in the center pictorially, so they're indicating this is another voltage step of some sort. They probably have the end. I don't know. Don't know what's this. Haven't looked at this. So that's basically what I think is going on here. This selector switch is selecting between the different B+ voltages. One of them is the rectified voltage coming from here, maybe elevated by this variable resistor. This is P4. I'm going to look at the instructions for P4. See what I can find here. I was totally wrong about P4. So P4 is adjusted here to remove the if your meter won't right here, if the meter deflects off 0. I remember doing this very carefully. And this is not going to change the output voltage. The only thing that would change the output voltage is that I think maybe the vacuum tube. Maybe I need to check that vacuum tube again. The 5U4. Do I have a tube tester? Is there a tube tester around somewhere? I'm going to test that tube again. Okay, I tested this tube in 2 other tube testers, and it tests just fine. There's nothing wrong with this tube. So it cannot be part of the problem. Transformer output itself, but there's a line adjust, so any problem be compensated for with the line adjuster. You'd find out you can't adjust the line high enough to boy, this is quite a serious problem. Now there was a capacitor involved. Let me take a look at that capacitor. Is there another capacitor in here somewhere? I don't even know. Let's take a look here. Okay, here we are. Here's the rectifier. There's a capacitor right there, 0.01, and that's right on the output from here. Didn't I say something about smelling something? There's also one down now. This is the one I think I've changed. So where's this one? Must be somewhere near the tube base. Could this guy be leaking out enough? Gee, yeah, I doubt it. I doubt it, but let's take a look. Let's try to find it anyway. Okay. So we would find this near the base of this tube, I would guess. see a capacitor here. This one here. This is not the kind I'd be worried about though. This is could that be it? Could that be the capacitor? There's another one right in here. And am I mistaken? No, these all look like resistors up here. There's the electrolytic one I replaced earlier, much earlier. Maybe this is a capacitor. I'm not even sure. Wow. So how can I identify the capacitor I'm interested in since it's not near here? I was kind of hoping it would be. Okay, I'm going to have to track it down. Okay, so this is the capacitor in question. These capacitors are highly reliable, very unlikely to be a problem, but I don't know what else to be suspicious of other than this transformer is no longer producing the same output it used to. How can that happen? Okay, transformers, they don't get weak over time, do they? I don't think that happens. So I have my thermal viewer here, and it might be interesting anyway to look around at a few things. And we'll see if this is getting hot, because if this is pulling down the B+, it's got to be getting hot at the same time. And again, I just highly doubt this. So we're going to turn it on, laying flat like this. I checked a few of the settings. I think everything's okay. There's obviously no tube in it. So I think we turn it on totally upside down like this. There we go. It's on. Yep, it's definitely on. Okay, so this guy here, I can control the color settings, so different temperatures will trigger the color. The color range is blue to red, like you would imagine. So blue is cold, so that's cold. You can see some in the green and red down here, some numbers written. That's the maximum and minimum temperature on the screen. And then this big number is the temperature dead center. There's a plus sign there, you can see it. Whatever that plus sign is over, like there's something over here. You read the temperature of it, 29 degrees. So something is getting to be, I'm probably seeing the top of the tube here. The view of this camera is incredibly broad, like it's really broad, so it's not easy to figure out what you're seeing. So we'll take a look at a few things here. Just leave the settings as they are now and just see if anything is popping up in any way. Oh, something. Well, okay, so I'm shining it at the tube here, and shining it. I'm looking at the tube. It's of course very, very hot. So that's the line control resistor. It's quite warm. Bias resistor has bias adjustment. Some of the resistors here are warm. That's a little bit surprising, isn't it? Well, they got a high wattage one there, and that's exactly the one that's warmed up. And its temperature is high, 38. So a really high temperature here would be 50, 60. For me, at 50 degrees, if I touch it, I feel like I'm being burned. By 60 or 70 degrees, you are being burned. So, okay. Just go around here and just see if I can find anything that's hot that I don't think should be hot. Not going to find anything there. So that's the tube. I can see the glass tube just over the top. One way to deal with these images is to block the thing you're trying to determine what you're seeing. So all I'll do is I'll block the tube, and you can see the red just disappears. So that's the tube for sure. And what about that capacitor? So it doesn't show up at all. We'll make this more sensitive in a minute, but again, there's a resistor over here, but again, it's a very high wattage resistor. No surprise that it should be warm. They expected it to get warm. There's nothing going on in here that is catching my attention, really. As for this capacitor getting hot, I mean, that's I would be really surprised if that was the case. Okay, the red thing that's showing up again is this resistor up here. So I'm going to make this more sensitive. Make it so that a lower temperature will generate a red result. Oops, wrong way. Okay, so now we'll look at this. See my finger. That's my finger. So this whole area is warming up. I don't know why. Why would that be? It's not warming up much though. You can see the resistors here. One of them's warming up. Sometimes, fingers a lot better letting you know the truth. There's no heat in here worth even thinking about. And I'm sure this capacitor is ice cold. How can I touch it? I don't want to touch it. I'm going to give myself a shock. Okay, one more time looking through while we've got this. Now that things have heated up quite a bit. There's lots of heat. Oh, I changed the setting here. So let me change it back. 30. We'll set it up fairly high now, something quite hot. Something has to be quite hot to show up. So this guy, the resistor in here, this switch is showing up. Oh, you know what? It's probably getting radiant heat from this tube is lighting up the switch here. It's probably what's happening. Can you see this? You can kind of see that the actual switch pattern and the terminals are sticking out. But I think it's just getting adjacent heat from here. If that's the case, then other things are going to show some heat too. Adjacent. But there's nothing of any significance. This big red thing you're seeing here, that's the other vacuum tube. That red thing is the light bulb down below. There's nothing getting hot in here. So now, there has been a couple of times where I thought I could smell something. So I'm going to keep this handy. And my thermal viewer here. I've used this all around my house, by the way. If you get it set just right, you can actually see cold air coming out of leaks in your house, wherever it might be. And you can actually see the cold air bubbling along and heading somewhere. It's pretty interesting. My house is in good shape, by the way, when it comes to heat retention and that. Well, where are we at now? We're at the point where really the transformer itself has to be proven out. There must be some information about the output voltages for this transformer, and we could also measure the primary if I can figure out what's what here. Look at these things. The wires going everywhere. But each terminal is numbered. So I think what we would probably want to do is consider the primary voltage on here. And I don't know. I'll stop and think a bit about it. Okay, let's see how this goes. I've got my vacuum tube voltmeter this time connected to terminal, forgot the number, the correct terminal. Anyway, I'm sure I spent a lot of time making sure I got this right. So the idea is we're going to turn on the unit. We're going to adjust the top panel adjustment here until the meter says 5 volts. Oops. The meter doth say 5 volts. When this says 5 volts, we then adjust PT9 to show a center reading up here. PT9? Not PT9? Oh my god. I tell you, man. Wow, I need a new memory, that's for sure. I'll have to make a note of that and remember to get a new memory. Let's see. So connect the AC voltmeter from ground to terminal 14 of PT4. That's what this meter is. Use a range of at least 10 volts. Well, okay, I'm on 15. Plug the line cord into any 110 volt outlet. Pilot light should turn on. Set line adjust control on front panel for 5 volt AC reading on this meter. Without changing anything, adjust P9 to get the meter on the machine to be in the center. Okay, let's see what happens here. I guess we need to turn some stuff on. So, okay, we'll turn this on. Yeah. Okay, you can see I get a reading already. Hopefully none of these panel adjustments really matter. I think they're all supposed to be snapped counterclockwise, probably over to the zeros for this. Okay, so we have 100 volts on here. Let's do that. We're running 115 volts onto this. I can tell from this meter here. Okay, so we want this to be 5 volts. So this is 5 volts full scale. So we see it is low. It's got to come up to here. No problem. I'm going to adjust it up to there. That's 5 on that meter. Just because. I'm going to check it with my other meter too. Pretty sure my VTVM is pretty accurate. Hey, yeah, pretty accurate. But let's find out. Because I think these digital meters are extremely reliable. I mean, so I believe. Okay, so we'll go to AC volts 5. And I should see 5 on here. Ground this guy. And do we get 5? Well, that's interesting, eh? That's not 5. Let's go with the digital meter. Wrong control, Jim. So if we use the digital meter, we're way down here. Maybe that's where the mistake... No, I used the digital meter last time, didn't I? Wow. So the thing is, this is the AC, and I've never calibrated my VTVM on AC. I don't usually use it for that. Come on, go to 5. Okay, so there's 5. Now the idea is to get the center to be in the center. I guess we gotta have this on line. Okay, so we're a little over there. So we'll take check it again. We're still at 5, and it's PT. What was it? PT9? Don't get this wrong. I'm looking for my mouse. Here it is. Let me peek at my computer screen here. Oh, it's already on the screen. PT without adjusting. Whoa, wrong spot. Without changing any of the above settings, adjust the internal line potentiometer P9 to locate on the power supply for center reading. Center of the question mark. P9. Okay, P9. There it is. Which one's P9? P9 is, well, I can do it with my hand. Okay, P9, adjusting. That's all there is to it. So now we check again, make sure it's still 5. 4998, sounds like 5 to me. Right on the center. That is done. Could that have changed things enough to make the tube test invalid? Can't imagine that. I really, what am I doing here? I'm not affecting the B plus circuits at all. I'm just calibrating this meter. or in a way I'm calibrating this control, I guess is really kind of what you're doing. Well, all we can do now is put the tube in and test it again and see what happens. But I just did not get the... I don't think there's any cigar coming here. Let me stop for a minute. Okay, this is the last thing I'm going to do today. So I think we're all set here for a 6C4. So turn on the power. Very good. Give this thing a chance to warm up. Give the tube a chance to warm up. And let the current draws settle. And then we'll do the line check just in a moment. I suppose you could be doing the short check while you're waiting. Don't think we really need to do that at all. Okay, so we'll set the line now. Okay. That bias is 4.8. So we're on the 10 scale. 4.8 is right up here. Okay, we'll check the line again. The line is good. 4.8 is good. Ready to test. Test. I think we got a higher reading this time. So now we're reading, we're on the 3 scale, we're reading, yeah, before it was 400, now it's 5, 6, 7, 8, 800. 800, but the reject point is 1300. Wow, that's just not giving me any kind of good feelings at all. Not at all. So let's just check again. The line, how can it be out? It can't be. Bias is on. Everything is on. Everything is good. Let's check the tube current. Okay, so the tube current on the 3.3 amp scale should be up the middle. It's showing it a little high. That's probably just again another. Could be all the calibrations I've done have gone off a little bit since I adjusted the bias, or not the bias, the line adjustment, because that would have meant previously adjusted incorrectly. Every time I set this to center, I would have had the tester not quite in the state it should be in. So previous tests were one way, now I've got this corrected, so test's going to be a little bit different. So this is probably just a calibration error. I don't know, when these things say they draw, I have not done filament current tests with any regularity. This is the only tester that does it. So I don't have any experience with how consistent the current draw is in a filament. If I put a different 6C4 in here, I get the same reading over and over and over, or is there some two things going on? They're not exactly the same right out of the factory, which is kind of unlikely. But over the course of their lives, the filament draw changes. I have no experience with these questions, because I've had no opportunity to test it. That's one of the reasons I want this tester to work. Okay. Maybe I'll do one more. Let's do the 6L6 test and see how it comes, and then I'll be done. 6L6. Good idea. 6L6. BGGG. BGGG. 26431 2 6 4 3 1 0 5200 0 5200 2.9 on the bias. Okay. Here we go. Oh, Okay, so I may have made a video error and I may have missed capturing the testing of this tube. So if I did, whoops, this tube still tests way low. 1300 is the throwaway point, or the sell the guy a new tube point, and the actual result now is 800 coming out. Just in case, because I think I may have made a video error. This is now set for 6L6. We're going to put them in. Okay, let's switch on. There we go. Fuse light came on just a little bit there. We're in test, and off. We have to make a bias adjustment and a line adjustment. The bias adjustment, let me get this up on my screen here. For a 6L6, the bias is 2.9 volts. Okay, we'll do the line adjust first. Well, we'll see if the bias is in close. So on the 10 scale, 2.9 would be somewhere around here. So put it close, go here, adjust this up just a touch. The line is good. Bias now, 2.9, just right there. I can't imagine that's throwing the line off. Nope, we're good. 2.9, definitely. Ready for the test. So this is coming in now on the 20K scale. It's a top scale at 4,000. This is a 4,000, just over 4,000. Tested this tube quite a bit. Take a look at the previous readings. This is tube number 2, isn't it? Yes, tube number 2. So 5,200 and 6,000 in 2 other testers, as compared to this one, which is saying 4,000. Well, we're getting closer. we're getting closer, but this isn't nearly as far off as the other one, is it? I don't know. I'm still like, oh, and what's the reject point? So we have to, like, you can't compare these things directly. So the reject pointer is 3825. So I'm actually in the good by a small percentage. Can you make this do good, bad? I'm only in the EM test. Well, let's do the EM test then. Turn this off. We'll do the EM test. It's BEBD8. BEBD8. Seem to remember doing this. Bias is set by number 14. So set it to 14. And everything else remains the same. Supposedly this tester is saying this is the better test, the EM test, than the GM test. Kind of surprising to me, but that's what they're suggesting here. We are ready to go. So checking the line again. Bias doesn't matter anymore. So we are ready to test. Way up in the good. There's no numbers involved here, are there? 6L6, come on, where are you? No, so they don't show a number, so I'm pretty sure it's just good and bad. This was really good. That's interesting. EM test working. GM test still falling short. Okay, that's my conclusion for today. Something wrong, don't know what. It's probably me. It's probably something I did, but I don't know what that is. So that's it for today, though. So thanks a lot for watching, and I'm sorry this is going on for so long. It's wearing me out, that's for sure, but I really want to get this guy going. Well, I mean, what could it possibly be? You know what it could be? It could be a defect in the transformer, the power transformer itself. Well, with that sad thought, have a great day. See ya.